First, we're going to start with the universal set. Magic. Okay, so the universal set is a general set that contains all of the elements under discussion. So if we're talking about this classroom and we're going to categorize you guys in different groups or different sets, the whole class would be the universal set. Or if we talked about the whole adult high school, and then this was one of the subsets of that, then the whole adult high school would be the universal set. Okay, and that's represented with the letter U and a rectangle. So when we talk about in relationship to Venn diagrams, you'll draw a box to represent the universal set, and you'll put a U in the corner of it, capital U. Okay, just like in that picture. Now, Venn diagrams were created by John Venn. A long time ago. There we go. Oh, it's not well put up. Okay. So, he came up with them to show set relationships visually. And for a lot of people, that makes the idea of set relationships easier to understand because a lot of people are visual learners. We see in pictures, right? Sight is our main sense. Okay. The universal set is represented by a rectangle, and subsets are ovals, circles, sometimes other shapes. You can make a Venn diagram with any shape you want. Circles are just kind of easier. And they're labeled with a letter. So our blue square U is our universal set. Our circle A is the subset A. Okay, and then we'll talk about this little symbol right here in just a second. That's called A prime. Sets. The universal set is every single thing that appears inside the rectangle except we don't count, oh, maybe I should make that a different color. We don't count the names, okay? So we don't count this U, because that U is the name of the universal set, and we don't count this A. These are the names of the set. Okay. Other than that, the universal set contains every single other thing in this rectangle, including what's in the circle. So our universal set for this particular set is square, triangle, number sign, and 5. So square, triangle, number sign, capital M, 5. That is our universal set. So everything that's inside the rectangle. Our subset A is only what's inside the circle. So square, triangle. And as you can see, a set can be a collection of anything, even stuff that is completely nonsensical, like square, triangle, number sign, and 5, which shouldn't mean anything to anyone. Okay. Now, finally, we have the set of elements that are in U that are not in A. Okay, so this whole rectangle is U. This circle is A. And when we talk about what's in U but that's not in A, we're talking about everything outside of the circle. All of everything that's in this area. So we have number sign, M, and 5. That's not. I said number sign and that dollar sign. Okay. So that's the set of elements in U that are not in A. Any questions about those 3 areas of the diagram? Nine and 7. 1, 5, 6, 9, and 7. So everything. 1, 5, 6, 7, 9. And A? 1, 5, 6. And the stuff that's in U but that's not in A? Not too bad? Where I talked about the things that were in U that are not in A. So I'm going to go back really quickly to this simple group. That's called A prime. That represents this set right here, the set of things that are in U but that are not in A. We're going to talk about what that's called in a moment, but that blue highlighted part is this C option, A prime.
Prime A to the first, or just?
No, it's an apostrophe.
Okay.
Yeah, it's not a one, it's an apostrophe. So just keep that in mind as we go ahead. All right, so we have two kinds. Well, we have more than two kinds. We have different kinds of sets in Venn diagrams. Okay, we have a disjoint set. They don't overlap. Okay, so in our universe, we'll have maybe some set A, we'll have some set B, and they don't touch, they don't share anything in common. They're disjoint. Then we can have proper subsets. Okay, where we have our set A, and then our set B is completely inside of set A. That's a proper subset. So like, if we throw some elements in there, something like that. This would have 1, 2, 3, something like this, where 3, 4, and 5 are in A, but only 5 is in B. So it's proper subset. Any questions on those two concepts? Think concentric circles on that one. Well, we talked about equal sets. Equal sets occur when you have exactly the same elements, the exact same set. And so we would say this is AB with a hyphen in it. So this is both sets A and B, but they're equal. They both contain the same elements, whatever those are. No, long arrow. Okay, so A and B both contain square and number sign. And then you have sets with some common elements. So you have set A going around like this, and then you have set B coming around like this. And these are this is basically essentially one set here. And this is overlapping sets. Okay, and so if we have sets with common elements, maybe this is 1 and 2, this is 3, and this is 4 and 5, and that's 15 or whatever. They share a 3. Okay, so the shared elements go in that middle part. Okay. So for example, they said A was all the people in this class that like comedies, and then set B was all the people in this class that like horror movies. Everybody that likes both would be in the middle. Make sense? Any questions on that so far? We essentially have 3 zones. Well, sorry, 4 zones. We have zone 1 is A, and that includes this whole circle. Zone 2 is the overlap, so the football shape in the middle. Zone 3 is B, which contains this whole circle. And then zone 4 is the stuff that's outside of the circles.
That's only in U.
In U, yeah. That's my rectangles apparently kept getting cut off. I don't know why. Let me fix the rectangle.
They're just indented, but they appear to.
There we go. I just fixed it. Okay, so U is everything. Now we're not, these ones, twos, threes, and fours, the Roman numerals, I'm just using those to differentiate the zones. So U contains all of the lowercase letters, guys. So A, B, C, D, E, F, and G. That's U. This is the universe. It contains everything.
The Roman numerals are just there for.
To talk about the zones.
Alright.
Okay, B contains everything in zones 2 and 3. Because it's the whole circle. So we have D and E. Okay? The set of elements in A that are not in B. Okay, A is this entire circle. So A is A, B, C, and D. But D is also in B, correct? So we only want what's in the light blue part, not the overlap. So A, B, and C.
So would that be B prime or?
No, not exactly. Yeah, it gets, B prime would be everything outside of this circle. So it would include A and the parts that are still in U. So we would have just this, which is not quite B prime. Then we have the set of elements in U that are not in B. Well, everything in U that's not in B includes this part of A that we already talked about, as well as this bottom part here in the rectangle. So we're looking at, basically for that one, everything in the rectangle except those two, right? Everything in U that's not in B. Well, these are in B. So we need everything else. So A, B, C, F, and G. And then we have that set of elements that are in both A and B. Both. Has to be in both. So not all of A and all of B, but the overlap. Okay. And on these kind of questions, that wording is going to be really particular in both A and B. Okay, and that's what let me know it was just the overlap.
Yeah, the both denotes that.
Yeah. If
If
it just
A
said
or
the
B,
set of elements in A and B,
it would be all.
it would be all of them. But because it said both A and B, it has to just be that overlapping football part. So you want to be really careful when you read these and make sure you understand exactly what area it's talking about. A. Set of elements in A. Did I just repeat the same exact letters? Yes, I
Uh-huh.
Well, okay, fixed it. So the set of elements in A. What do we got? Anybody? The set of elements that are in B but not in A. Okay, set of elements that are in U but not A. Yeah, so everything that's outside of that A circle. So 3, 7, 9, and 10 and 4. The set of elements that are in U but that are not in A or B. Okay, and the set of elements that are in both A and B. Seems like you guys like a compliment like you give somebody when you like their shoes. Okay, different kind of compliment. Okay, so the complement of a set is symbolized by A prime. Okay, we call it A prime. It's A apostrophe. It's the set of all elements. Sorry, I didn't erase everything. And the universal set that are not in A. So if the white circle is A, all the blue is the complement of A. so basically a complement is not something. Okay, so we can do it in a set builder notation. So X is an element of U, but it's not in A. That's the complement of A. So if I have elements in here, in the universe, okay, A, well here, we'll do our universe. The universe is the set that has triangle, circle, square, rectangle, parallelogram, and trapezoid. Okay. A is triangle, circle, square. And the complement of A, which is not A, would be rectangle, that's bad rectangle, rectangle, parallelogram, trapezoid. Okay, so whenever you see this little apostrophe, go outside of the set you're talking about and see what's there. So the complement of this classroom would be kind of everybody else in the building that's not in the classroom right now. And if U is the set 1 through 9, and A is the set 1, 3, 4, and 7, A prime is what?
2, 5, 6, 8.
That's good. I could have done that without the picture even. You know how you do it without the picture? I would just go into, if this was like, I didn't have the picture, I would say, well, here's A, here's U, and I would cross out the things that were in A, and then everything left is A prime. Intersections. When we talk about an intersection in the real world, what are we talking about?
Well, two lines
Two,
that cross at a
yeah.
90-degree angle.
Roads that
Intersect at a 90-degree.
cross or, yeah. So, in set theory, the intersection is the overlap. So if we talk about in a Venn diagram, we have the two circles, two sets. This is the intersection. It's where the two sets meet. If you think about two roads, their intersection is where the two roads cross, and that square is both roads, right? Does that make sense? That's the same thing here, except we have a football shape.
So you say meet. Does that mean if they were to just
If they, well, if they just, they won't touch unless they have something in common.
Yeah.
So if there's even just one thing in that set, that's an intersection.
That's the,
Yeah.
okay.
The symbol for intersection is an upside down U.
Oh.
So this means intersection. Okay. So A intersects B. If this is set A and this is set B, then we're talking about this football shape in the middle of the two. And intersections can be more than one set. It could be like A intersect B intersect C, and you get, you know, 3 circles that all meet at one place.
Like a rounded triangle.
Yeah, that's actually a hyperbolic triangle. Okay, so when we talk about an intersection, it's the things that are in both sets. So 7, no 7. 8 in this set and an 8 in this set. No 9, then a 10, no 11. So the intersection is only the two that they have in common. Yeah, 8. 1, 3, 5, 7, 9, 2, 4, 6, 8. Do they have anything in common? No. So there would be nothing in the intersection. So the intersection would actually be an empty set. And you have no elements in common. Okay, so essentially there's not an intersection at that point. 1, 3, 5, 7, 9 intersecting the empty set. What do you think would happen there? Well, it'll still be an empty set because there's nothing here for it to even ever intersect with, so there's not going to be anything in the intersection. So that would also be the empty set. If an intersection is like where two roads overlap, and the square, the part where the roads are overlapping, if you think about a union in the normal non-math world, a union is like a marriage, right? Marriage.
Two separate things becoming one.
Two separate things becoming one. And when that happens, you don't only keep the stuff you have in common, all of everything comes along with it, right? Like you combine your two lives, everything that comes with it into one, except maybe the ugly chair or something that he has to throw away. But combining two things, joining into one. So with a union, it becomes everything that was in both sets. Okay. So the symbol for union, that one's pretty easy to remember. It's a U. Intersection is just upside down. Okay, so union, and you combine everything in both. Okay, so if I have these two sets, actually they don't even have to be overlapping. They can be anywhere around each other, or they can overlap or not. But if I have A and I have B, the union tells me I take everything in here and everything in here and I add them together. So if it's a list of numbers, I put both lists in one big bracket. If it's all the furniture in both of your houses, you try to cram it into one house. Like I said, with an intersection, we just wrote down the numbers that they had in common and overlap. With a union, we write down everything. There's a 6, there's a 7, there's an 8, there's a 9, there's a 10, there's an 11, and there's a 12. So I got the 6 from here, then 7 there. They both have an 8, 9, they both had a 10. So just crammed them together. Here I have all the odds, here I have all the evens, so the union is going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Whereas before, when we were talking about an intersection, that was the empty set, because they had nothing in common. Now that they're united, we just list everything. And then, if you have a union with the empty set, this doesn't bring anything to the table, so you just list the previous set over again. Okay, so this is like somebody that has a bunch of stuff marries somebody that has nothing. Good? Yeah. We kind of did this already in the examples. When we came up with that if you intersected with the empty set, you didn't have anything in common because there was nothing there to have in common. So it's, and then if you intersect, or sorry, if you unionize with the empty set, You just did that being yourself. So this is kind of like multiplying by 0. Right? If you multiply by 0, you get 0. So if you intersect with the empty set, you get the empty set. It's the same kind of idea. And this is like when you add 0. When you add 0, 2 plus 0 is just 2. Nothing changes. You don't get anything out of it. So if you kind of memorize this, you don't have to work it out. But then if you don't memorize this, that's okay because you were able to work it out before anyway. So this is just like a rule that you can use if you want to. Let's talk something about the language of unions and intersections. Okay. With intersections, the word we use is and. Okay. So when you see that word and, that means only the things that are in both sets. Okay. If we're talking about a union, unions are represented by the word or. And that means everything in both sets. So this is the overlap. Okay. So if I say the elements is set A and B, I'm just talking about and. Okay. All of this is or. Does that help? So if you see the word or, everything in both circles. If you see the word and, only the overlap in the middle. When we talk about operations in regular numbers, we talk about add, subtract, multiply, divide, exponents. But we have set operations, and set operations include intersection, union, and complement. Okay, so these are our set operations. Complement, def prime. Okay, guys, you always want to do exactly the same thing as you would do in order of operations. You remember PEMDAS?
Please excuse my dear.
Yeah, P comes first, parentheses first. Parentheses, yeah, we don't have exponents in this book. So we're going to have parentheses first, and then after parentheses, it'll be the union, intersection, or complement. So in A, this example, lowercase a, I have A union B in parentheses first. Okay? No, that's union. Yeah, it's,
Okay.
Sorry. That's the wrong U. Okay, A union B is everything in A and everything in B. Okay, so I've got 1, 3, 7, 8, 9, and 10. That's all of A and all of B. So that's the parentheses. Okay. Then the complement is outside the parentheses. So I do that next. So A union B prime, if this is all of A union B, the complement is everything that's not that. So I'm going to take out of my universe 1, 3, 7, 8, 9, and 10. So whatever's left is 2, 4, 5, and 6. don't have parentheses in B, I have A prime intersect B prime. Since I don't have parentheses, I do the primes first. Okay. So A prime is everything that's not an A. So the complement, right? So 1, 3, 7, and 9 was A. I'm going to take everything that's left over, and that's 2, 4, 5, 6, 8, and 10. Okay. And then I need to do the B one. So B was 3, 7, 8, and 10, so I take those out. And I have 1, 2, 4, 5, 6, and 9. Then I have the intersection of the two. And the intersection is the things that they have in common. So they have a 2 in common, a 4, a 5, and a 6.
Oh,
Yeah.
so the symbols, when it's a U, that's what they don't have in common, and when it's an N, that's what they do have in
The
common?
U is to put everything from both together.
Okay, and the N is just what they have in common.
Yeah, they overlap, what they have in common. Okay, so our order of operations, oops, I erased too much. We're gonna do parentheses first, and then complements, and then union, not that kind of U. I'm so used to union or intersection. Okay, that's going to be our set operation, order of operations. So it'd be like PCU. Okay? Remember that these are just telling us the location. We're going to not pay attention to those. That's just the zones. And this U and this A and this B are the names of the set, so those are not our numbers. Okay, A union B. That's everything in A and everything in B. So pi E, the square root of 2, the square root of negative 1, e to the pi I, 10 to the 100, and 2 out of 0. So I just listed everything that was in the first circle and everything that was in the second circle. Now, A union B complement. Fine. We already found A union B. So this is everything that's not that.
So that's not, it's not an income.
Yeah, why did they pick that number? Oh, no. Hold on, I don't know, I just did. If A union B was everything in here, this symbol is the stuff that's not that, which I just changed the number, but what is that going to be?
66.
66. See why I changed the number?
Yeah.
We don't like that.
Can you run through this? It's everything that's not.
So if this is the union, right? So this is everything in these two circles. Once you put that apostrophe on it, you're talking about everything that's not that, which leaves us with 66. Yeah, so this symbolizes not that. Okay. If I talk about A intersect B, we're just talking about the overlap. So square root of 2 and square root of negative 1. And then if I go to the not factor. I'm talking about every single thing that isn't this. So we leave this out, then we list all those. So we have pi e to the pi I, 10 to the 100, 2, and 66. Okay? So every single thing that was not in that football we overlap.
So you think you need to?
I don't.
No, I don't.
Okay, here we have a not A. Okay, so everything that's not A, I'm going to circle in yellow real quick. So we're going to do this. Not A. A is this, so this is all the not A stuff. Okay? Intersecting with B.
Which would be zero.
This is B. This is not A.
Is the universe intersected?
This one won't count. The one outside of B, the 66 won't count. We can't use that, but this yellow circle here intersects inside of the blue circle for B, so it'll be everything inside this circle. Does that make sense?
Mm-hmm.
So we'll have e to the pi I, 10 to the 100, and 2 aleph sub-0. Okay, now I'm going to go to green for not B. So we're going to have A union not B. Well, what's not B? Pi E and 66. And we're going to say A union not B. So it's going to be every single thing in A and this 66.
Oh, so this
Would
one.
it continually intersect?
Including the intersect, because this little green circle here is the not B. But the whole big A circle, we take every single thing inside the A circle and everything in the green circle. The fact that these overlap doesn't really matter. So I have pi b square root of 2, square root of negative 1, and 66. Let me read it to you. Okay, the formula for the cardinal numbers of the union of two finite sets. Finite set number, right? So if I have set A, and let's say the cardinal number of set A is 6. Okay? And the cardinal number of set B is 10. Okay? To find the cardinal number of the union of those sets, I have to find the cardinal number of A, cardinal number of B, and how many in the set overlap. So I'm going to make sets really quickly. So I'm going to say A is 1 through 6. And I'm going to say B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, okay. So A is 1 through 6 and B is 4 through 13. Okay, the cardinal number of A is 6, the cardinal number of B is 10. How many elements overlap? This is the number of overlapping elements. So how many numbers do they have in common? 3. They have 4, 5, and 6 in common, right? So we take 6 plus 10 minus 3. 6 plus 10 minus 3. So the new cardinal number would be 15. It looks complicated in the formula, but you're going to take the number of the sets from one element, the number of sets from the other element, and then subtract how many they have in common. Okay. Not too bad. Alright, so, we have a survey about a blood drive. And we have 490 students who are willing to donate blood. 340 students were willing to serve free breakfast, and 120 were willing to do both. First of all, I'm going to go ahead and draw the Venn diagram. And I'm going to call the blood donors set A and the breakfast servers set B. Oops, I didn't make that last one big enough. Okay. We've got 120 that are willing to do both. They go here. $490 were willing to donate blood. Well, 120 of those people are here. So I'm going to take 120 out of the 490 to find out how many are right here that don't want to do both. So that's 370. And then 340 were willing to serve breakfast, but that's still 120 will do both. So that's going to be 220. How many students are willing to donate blood or serve breakfast? Well, with the Venn diagram, it's easy to see, add the 3 up, right? If we're using that cardinal number, the intersectors are 120, and so if we use that formula, you'd be 490 plus 340 minus 120. So you can do this either way, whichever way makes sense to you. Where'd I get that?
We're using the original numbers, not the ones.
The original numbers from the problem. This is the 490 that are willing to donate blood. This is the 340 for breakfast, and this is the 120 for cook. These will both give you the same answer. And that answer is a number. Okay. So there's more than one way to get at these. You can draw a picture, or you can use that formula. Okay. So this is 2 methods. Or you can do both.
Kills me.